Hi, I thought I would make a new video. This video is a little bit about how the type system works in Mavis. So Mavis is the type system library that underpins Selectrix, and Selectrix is a compile-time static typing for Elixir. So what Mavis is capable of doing is looking at Erlang types and doing some key reasoning about how these types work and interact together. So to start off with, I just wanted to give you an example module and how we create a type. And we create a type by using this type keyword. And we can assign a name to any type. And importantly, ranges are valid types in Elixir and Erlang. And the way we can check that is by doing using the T keyword in the console, which is basically like docs for types. So let's do example.basicRange. And you can see that it knows that the type of the quote basic range is the range from 1 to 5. So the way Mavis handles logic and calculations around types is by reifying these Erlang types as structs, and doing some magical things with Elixir's protocol system to be able to like really generate clean code around how to handle these types. Let me show you one of the things that I use. In this case, it's going to be type.operators. Don't ever use this in prod or any code that's going to hit prod. You should only use this using statement in your test or in the console. And so, for example, if we take take the range 1 to 5 and union it with another range, say 4 through 8, we get out the range 1 through 8, which is the type union of anything that is in the integers from 1 to 5 and anything that is in the integers from 4 to 8. Similarly, it can do some pretty advanced stuff, like, for example, it knows how to fuse ranges into the appropriate combined range, and other types too. For example, if you fuse integers with other types of integers, it will, generally speaking, do the right thing. Okay, so that's union. I also want to show you intersection, which I don't have an operator for. Intersection, and so 1 through 5, and let's do 3 through 8. And so the intersection of the ranges 1 to 5 and 3 through 8, of course, is going to be the range 3 through 5. And so those are kind of two of the basic operations. I'll probably later on do some sort of video about a special operation that I've created just for the beam called usable as, which is not the same thing as intersection, which you might expect it to be in other type systems. But real briefly, let me restate the goal of intersection. The goal of intersection is that if I have an object, or if I have data that fits in this intersection value, that means it is it's guaranteed to be both valid for the first one and the second one. Okay, so with that in mind, I'm going to uncomment a slightly more complicated setup here. And so I have these two maps, one which can optionally have keys in the range -10 to 6, which yields an integer, keys that are in the range from -5 to 5 that yields an atom, keys that are in the range from 6 to 10 that yields an integer. Now, this is kind of a silly map spec. You probably would never run into something like this in the wild and prod. You shouldn't make a type like this, but the point is that if it's flexible enough to handle a pathological sort of map like this, then it'll likely be flexible enough to handle most of the use cases that you'll ever run into. And what we're going to do is we're going to take the intersection of this map with the intersection of with this map, which takes negative integers, which can have negative integer keys that will always yield negative integers. It will have if it has a 0 key, then that will yield an atom. If it has a positive integer key, that will yield a positive integer value. Now, what's the intersection? Let's look at this like segment by segment. If we have a integer that's less than 10, then it's going to satisfy this map if it had a value of a negative integer, but it's not in the first map. So anything below -10 is not going to be in there. Any map that has values that are less than -10 are not going to be in the intersection. So we'll start from -10 to -6, in which case map 1 requires it to be an integer, map 2 requires it to be a negative integer. So the between -10 and -6, it should give a negative integer. Okay, so between -5 and 5, map 1 requires it to be an atom, but map 2 is going to require it to be either a negative integer or positive integer if it's anything besides 0, and that doesn't mesh with map 1 requiring it to be an atom. So a map that's in the intersection cannot have optional values between -5 and -1. Likewise between 1 and 5. But if it's 0, they both demand atoms. So we could have an optional 0 value that yields, or 0 key that yields an atom value. Finally, on the other side of the number line, if it's between 6 and 10, it can be a positive integer if it's in map 2, and if it's between 6 and 10, it's an integer. It needs to be an integer for it to be map 1, so the intersection can take keys between 6 and 10 and yield positive integers. And beyond 10, nothing. So because it won't satisfy map 1. So let's first pull these values out. So T1 equals type dot fetch type example map 1. And so you can see that we pulled that from the data. We created what's actually a struct. And so, for example, you can see this by doing T1 dot, see it's a struct of type map, or type dot map. And then we can also similarly fetch the second one. And so that gives you exactly what you would expect. Now let's take the intersection. And you can see that it has correctly identified that the intersection of T1 and T2 will take values between -10 and -6, or keys between -10 and -6, and yield a negative integer value. Nothing between -5 and -1. An optional key of 0 will give you an atom. Nothing between 1 and 5, and optional keys between 6 and 10 will give you positive integer. So that was a considerable amount of work. If you want to see the code, I'll post a link to the GitHub in the description below. I mean, and this took me about half a day to figure out how to do this one thing correctly. That's about as much time as it took for me to build a file browser in Phoenix LiveView. So, and I'll post the link to that video for that one as well. All right, well, take care. Hopefully you enjoyed this little progress report on how type inference is going on in my Elixir project.